Okay, so I'm going to make a sample. I'm going to make a population. So it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then it's got that repeated again. So this is just some population data that I'm just making up here. Okay, maybe this is, I don't know what it would stand for, but just a population. So my population is, say, going to consist of this 100 pieces of data. So I want to go down to, this is the last one. It goes down to 102, and it starts at 3. So this is 100 pieces of data. You can see exactly what's in here. It has 10 ones, 10 2, 10 3s, and so on. Now we can figure out the standard deviation of this pretty easily in Excel. We just do this. Maybe I'll click up here and use this thing. You can use this. So function, insert a function, and let's look up standard deviation. Now they have, let's check here and look up statistical and look up, actually, I guess we're going to do variance. Well, let's just do standard deviation instead of variance. So let's look up the formulas that they have. So you can see they have STDEVP, STDEVS, STDEVA, I don't know what that means, STDE, I don't know what that means either. And I think I left out one. Well, anyway. Maybe this means standard deviation. Anyway, so these two, one of them is the formula for the population. That's the one that we would expect. It's just dividing by n. Anyway, let's use that here. So click it. And it says it's guessing that it wants F3 to F102, which is right. And so the standard deviation of that data was 2.8. Okay, that's kind of estimate of the spread of the data. So the data goes from 1 to 10. All of them go from 1 to 10. Obviously, the mean is what? I guess obviously. The mean is 5.5. And then the standard deviation is about 2.8. Okay, so that's the standard deviation of this population. Now, what I mean by trying to show you which formula would be right is, if we're going to take a sample of here, okay, so suppose I take a sample. Suppose I take this one, just at random. I'm just going to take this one, and this one. I'm just doing this at random, and this one, and this one, and this one. How many is that? 5, maybe one more, and this one. Okay, so that's a sample. Now, what we were saying is we could calculate the standard deviation of this and use it as an estimate of the standard deviation of the whole thing, which we already calculated as 2.8. So we could use this, though, the standard deviation of this, as an estimate of this, because think of it, if you didn't have just 100 numbers, but you had 1,000,000 numbers and you didn't have them all lined up properly, they were just on paper, so you wouldn't want to have to transfer them all to an Excel spreadsheet or something. So you couldn't figure out the standard deviation of the whole population, but you could just take a sample and then calculate the standard deviation of this and use it to estimate the standard deviation of this. Well, it can be shown mathematically that it's better to use this formula on the sample. In other words, we'd use that formula with n-1 in the denominator to calculate the standard deviation of this thing as an estimate of this thing, this 2.8 that we actually know it is. So it's very weird that that's true, but it turns out that it is true. So it's better to divide by n-1 if you're trying to estimate the standard deviation of the whole population, it's better to use n minus 1 to estimate it rather than just n. Now that's here they're talking about for the variance, but it's the same thing for the variance of the standard deviation. You should use n, or rather you should use n minus 1 from the sample to make an estimate of what the real population is. Okay, now, so that's just a mathematical fact.